All right, welcome back to another special edition of Math with Zord. We are now into section 4 of chapter 8, which means that we are halfway through. There's 6 sections here, so got the first 3 done. We're starting the second half. It's all downhill from here. All right, let's go ahead and jump right in. Last section we were talking about quadratic trinomials when the first number, the a, the letter or the number in front of my x squared, was equal to 1. This time, we're going to take a look at what happens when a is equal to some other number. Okay, it's not that much different. You just have to do one extra step. So here's our first step. We're going to multiply a and c, so the first and the last numbers. Then we find the numbers that numbers that multiply to a times c and add to b. Replace b with those numbers, and we're going to factor by grouping this time. So if you don't remember what grouping is, make sure you go back and review section 2 because it's going to come back up and we're going to have to do it again. All right? So let's jump into this first example and see how this process works. First thing we're going to do is multiply a and c. So take 6 times 5, and we get 30. So then we're going to set up our chart again. Again, some of you probably won't have to, but we'll do it to help us out. So we want the factors of 30, and we want it to add to be 17. Easiest one to start with, 1 times 30. Problem is, that sum is 31, so that doesn't work. Next one, 3 times 10. 3 times 10 is 30, but 3 plus 10 is 13, so that doesn't work. What about 2 and 15? 2 times 15 is 30, 2 plus 15 is 17, so the ones that we're going to use are 2 and 15. Now here's where it's different. What I'm going to do is I'm going to take the 2 and the 15, and I'm going to rewrite the 17 with those. And you're going to see how I'm going to do that in just a minute. I have 6x squared still. And then instead of writing 17x, what I'm going to do is I'm going to write plus 2x and plus 15x. And I can finish that out with the plus 5 that I already had there. Okay. I put it in the colors so you can see where the 2 and the 15 came from. I have this 2 and 15 where the factors over here. Then all I did was take those and put them into the equation up here for 17. Because if you're looking at this and you pay attention and you remember that we can simplify it, we can do 2x plus 15x to get 17x. So all we did was expand it for a second until we can factor it. Okay. Now we have 4 terms. The way we factor any 4-term polynomial is to group. So I group them. I notice I can pull a 2 and an x out of this first term. So I do that. 6 divided by 2 is 3. I pulled out one of the x's. 2x divided by 2x is 1. I notice I can pull a 5 out of the second term, and I end up with 3x plus 1. These match. Always check that. And I end up with 2x plus 5 times 3x plus 1. Okay? It is a little bit longer of a process when a is not equal to 0, but it's still not that much different. It's nothing new. It's just doing the same steps we've always done between factoring the trinomials and grouping. You're just putting the two together into one problem. Okay? So that's why it's so important in math to understand one concept before you move on to the next, because they usually get used within each other. Okay? Let's go ahead and try number 2 down here. So again, the first step, first times the last to get 21. So I need numbers that multiply to 21 and add to 22. Well, that seems easy enough. 1 times 21 is 21. 21 plus 1 is 22. Not a whole lot of thought that goes into that one. Okay. So I'll take 1 and 21, and I'll rewrite it. 7x squared. Replace the 22 with plus x plus 21x. plus 3. Okay? We have 4 terms, so we group it. I see in the first term, all I can pull out is an x, which leaves me with a 7, an x, and a plus 1. I can pull a 3 out of the second term. 21 divided by 3 is 7x. 3 divided by 3 is 1. They're the same. So I end up with x plus 3 times 7x plus 1. All right? Again, it's nothing you haven't seen before. We're still finding the factors like we did in quadratic trinomials in section 3. And now we're grouping, which we did in section 2. So the only new step introduced in this section is multiplying a times c, the first number times the last number. Okay? So let's go ahead and flip it over on the back. We can see something. Sometimes you're going to notice that a, b, and c have a common factor. Okay? 3, 24, and 15. If you're astute, which means you're paying attention, you're going to notice that you can divide each of those by 3. So we can go all the way back to section 1 to the whole distributive property type of factoring, and I can pull a 3 out front from the start. If I divide each of these terms by 3, I end up with x squared. 3 divided by 3 is 1. 24 divided by 3 is 8. And 45 divided by 3 is 15. So 3 times x squared plus 8x plus 15. Okay? All I did was do the reverse distributive from section 1. Again, if you don't remember, go ahead, or sorry, that was part of section 2. Go back to section 2 and rewatch that one also. Okay? Now, I see I have a trinomial here where a is equal to 1. So that means I can go ahead and find what multiplies to 15 and what adds to 8. Okay? And we think about that, we could get 3 times 5. 3 times 5 is 15. 3 plus 5 is 8. So then I can go ahead. I keep this 3 out front. Then I usually want to put a bracket when I'm doing this, because now I'm going to end up with, oh, sorry, you don't need a bracket. My mistake. Now I end up with x plus 3 and x plus 5. Okay? We take a look. It's completely factored. There's nothing else I can pull out. There's no other x squareds anywhere. Now it's done. Okay? So that's something you always want to look. The first thing you always want to check to see is if there's a number you can pull out, divide all the terms by, and do that reverse distributive property that we saw in section 2. Okay? So that's what we do there. Divide everything by 3. It simplifies the problem. Then we don't even have to do that whole multiply the first times the last thing with all the grouping steps. It goes much, much quicker as soon as you recognize that I can divide something out there. Okay? Sometimes we'll see that polynomials cannot be factored and they're already considered prime, meaning there's no two things that multiply together to get the other one. Okay? So if I have 2x squared plus 5x minus 2, we're going to take the first times the last, 2 times negative 2 to get negative 4. Set up my chart. I want to know what multiplies to negative 4, and I want to add to 5. Well, let's take a look at this. I can do 1 times negative 4, but that gives me negative 3. I can do negative 1 times positive 4. That gives me positive 3. Or I can do negative 2 times 2, which gives me 0. Okay. There's no other options here. Those are the only 3 sets of numbers that multiply to negative 4, none of which add to negative 5. So therefore, we can say that this is a prime expression already. It's a prime trinomial. Okay? So, in summary here, first step you always want to look at when we're going to factor is to see if you can pull something out using that reverse of the distributive property from section 2. If you can't, go ahead and multiply the first number times the last, like we did up here. First times the last, set up your little chart. Then you have your 4 terms by replacing b, group them, and you're done. Okay? So, we'll be back with section 5 next. Section 5 is going to be talking about some specialized expressions that we can factor called perfect squares. And then section 6 we'll be talking about how equations can be solved with factoring. All right? So I'll see you in class, and good luck. Bye.